Hello again. It's time for the final session of our track. While the world is transitioning from the industrial revolution to the new data revolution, data science and machine learning practices have matured over the last few years, leading to more understood and robust realizations of data science life cycles. Without further ado, let me introduce you our final session, which is Data Lifecycle with Python. This session will be conducted by Mr. Sahan Bulathwela. Mr. Bulathwela is affiliated to the UCL Center for Artificial Intelligence, currently contributing to the X5GON and Human AI project. His research interests lie on the theme improving recommendations of educational content to lifelong learners. Before joining UCL, he has worked in several research and advanced development roles both in the Silicon Valley and in London in a range of domains from cybersecurity to personalized advertising, where his expertise in user state modeling, big data, and machine learning were used for data product development. At UCL, he continues research into the role of AI in education while leading the development of the intelligent learning platform www.x5learn.org. A warm welcome from us, Mr. Bulathwela. The platform is all yours.
Can everyone hear me well? Great. Yes. Hello, everyone. Good evening, and I see it's the latter part of the day, so I'll try to make this as exciting as possible. At least it is exciting to me. I'm excited to do this in PyCon Sri Lanka. It is I would like to thank the organizers for this. So today I'm going to speak a bit about data science life cycle with Python, from chaos and uncertainty to systematic progress. As you know, data science, building data products and data science related models have a lot of uncertainty. So in today's talk, what I'm going to do is I'm trying to first look at it in a developer's perspective to show you and argue that there's a very good, rich and diverse ecosystem in Python to do different elements of data science lifecycle, and then also look at it in a strategic or a director's perspective, where how you can look at adopting data science and AI in a business organization in a systematic way where you can deal with the chaos systematically. So I got a very good introduction, and I thank everyone, the organizers, for that. I'll just brief you a bit on this stuff that was not there. So as it was mentioned, my current research is around state-based recommendation systems, that is using the learner's state in terms of knowledge, interests, in order to identify what good learning pathways they should be taking using automatic methods. And we use a lot of Bayesian modeling for that. And recently I've been from that working a lot on AI for social good related areas, and also disability innovation, how we can use AI to help disabled communities. And apart from that, I also play certain advisory roles or consultancy roles in various university labs across University College London. And also I work with a few charity organizations such as Knowledge for All, KaiTech, to help people be closer to AI and get more use of it. You can also get a lot more information about what I do and how to contact me through my personal website. When it comes to data products, the common conception is that this is a tug of war between the strategic people in organization and the people who have to really pull the rope, who are the programmers. And usually in a strategic or a director's perspective, you want to cut costs, gain competitive edge over your competitors, go to market as soon as possible. You need new products that can wow the customers, but you need to reduce the overhead. And you always look at, everything I do, everything we do in this organization should lead to profits or success. That's kind of the objective or the view that directors have. And then we have the programmer who needs to make sure that they can manage their workload and the requirements are specified clearly and the timelines are manageable. On top of that, they need to manage the tech debt so that they can build maintainable, sustainable defensive systems on the long run. And at the same time, you don't want to end up with staggering projects where you have to keep doing the same thing and being stuck in the same place, which affects people's career development. And engineers like to be stimulated. So people think that these are two ends, and there's a constant pull when we look at data products. However, I would say, this is more like a myth. And what we should be thinking about is it's actually not that these two are need to be a compromise, but more of an alignment where you have a communication mechanism where, the strategic people can manage the expectations at the same time. The developers can do a good job, which will in long term bring a lot more profit and a lot more cost efficiencies. And in order to sort of convince you to do this and do this in Python, I'm going to first look at a developer's perspective and convince you that there are various different tools in Python that can be used in different parts of this pipeline. And then move on to the strategic side where you can say, okay, now you have these tools. How do you actually approach the process of putting these things into your organization? So when you're looking at a data-driven model or a machine learning model, usually there is a sequence of processes you do, from understanding to the problem to deploying the model into production. And today I'm going to use an example project that I conducted with one of the students in Sri Lanka, Mr. Devinda Benayaka, who's a final year statistics student at University of Colombo. This project I supervised with for him, and the objective was to detect the reliability of news articles in Sri Lankan media. And in order to do this, what we did was we collected English articles, because from the previous talk, you learned that, natural language processing, when it comes to English, there are a lot of tools and resources available out there. So what we did was we identified certain reliable news sources, such as newspapers like Divina, Daily News, etc., and TV channels. And then we also identified unreliable data sources, such as Gossip Lanka or Lanka e-news type of satire or gossip-based sites. And with this, we created a label data set of 12,700 observations. And from them, we extracted stylomatic features. That is like things like the length of the article, the type of vocabulary that is being used. Are they using simple words? Are they use emotional words? This type of stylomatic uh, indicators. And the objective was to try to predict if the article was reliable or unreliable, not looking at the source itself, but looking at the content representation of the material itself. And based on this, the objective was to build a machine learning model that gained test accuracy of 78%. That's pretty much like 8 out of 10 articles would be accurately classified. And to do this whole pipeline, we use Python. And in terms of the process, how it looks like in understanding the problem, you have to read a few papers, identify what type of data you need, and then we go into getting our hands dirty, where Python comes into rescue. So here in this particular project, we use web scraping. So we use the Python plugin for Selenium to use it as a headless browser. We also use certain APIs to get data. So we use the Python requests. And once we have the data, we need to clean the data. We need to extract the natural language features out of this data. To do this, we used Pandas, one of the libraries that most of you might be familiar with. And then we use Natural Language Toolkit, which is an NLP library that is available in Python. to do things like word tokenization, to extract the stemmed version of the word, to may tag them with part of speech, then to do stop word removal, etc. And then we go to the development of the machine learning model. So in this particular area, in the modeling and model evaluation area, scikit-learn, one of the most mature machine learning libraries in the world right now, played a huge part, where we used it for vectorizing these words. We the previous talk talked about TF-IDF computation, so we extracted those features, and finally we wanted to evaluate the model, where we use cross-validation and certain classification metrics. And we also use this library called SHAP, which allowed us to explain the model, for example, to see what different words play a major role when it comes to detecting reliability or unreliability of a news article. And finally, when we wanted to deploy to production, to use it as a service, we wrapped this machine learning model in a Flask web application and exposed it in the form of an API. So this seems like a fairly straightforward sequence of activities. However, in real world, it is not a sequence, and it is much more sensible and convenient if we can introduce a few cycles into this process. And there are different types of cycles you can introduce here. One of them is a short cycle, which is much more short-lived, and it is an iterative process that happens within the model development itself. And then you have longer cycles, which are much rarer and less often, less frequent. But as any process, data and business landscape change. And with that, the models that we have developed using previous landscapes become invalid or out of date. And we need mechanisms to detect that and then reiterate or revisit, building new models that are much more defensive to the changing landscapes. So this is the second cycle. And this pretty much makes a very reliable sort of data lifecycle that allows you to constantly keep up to date with the changes in the data landscape. And in the previous example, I convinced to you that to do most of the things in the sequence, there are Python tools that are available, which is a subset of Python tools that I explained. However, there are much more. For example, there's libraries like Beautiful Soup that allows you to do much more customized scraping. And most of the time, the data that we want for our machine learning models come from ETL processors, where you can use things like PySpark, which is a distributed computing framework, or other tools such as Kafka, which are streaming services where the data can be extracted from. And then when it comes to data preparation, you have things like NumPy that would allow you to do exploratory data analysis. And for different types of applications of machine learning, there are specific libraries. For NLP, in the previous talk, we heard about GenSim, which is a NLP library. Then there's also Spacey, which is another industry-scale natural language processing library. For computer vision, you have things like OpenCV. And for visualizing our data and trying to understand this data much better, you have visualization libraries such as Seaborn, Matplotlib, Bokeh for interactive visualizations. And then when we go to the modeling and evaluation as well, because these two come hand in hand, most of the libraries we find contain both the modeling and the evaluation components. And there you have things like stat models that do very vanilla model fitting, then scikit-learn, XGBoost type of conventional machine learning frameworks, then deep learning, which is a very new up and coming popular subset of machine learning families. There are very mature Python libraries such as TensorFlow and PyTorch that are available right now. And if you don't want to be full-on data scientist and let data itself drive the model selection process, you have these AutoML libraries such as Teapot or Ludwig that uses things like genetic algorithms or that uses Bayesian optimization to look for a very large range of features and models and try to identify what model would be more promising with minimal human intervention. And then when we go to the final stage, one of the most common ways to expose a machine learning model to industry or to external stakeholders right now is via APIs. And you have mature web application frameworks such as Flask and Django in Python ecosystem to do that. However, we haven't spoken at this point about these two loops and how we can incorporate them and make them game changers or make your life easy as a data scientist or a data analyst who has to deal with this messy data. And today, what I'm going to elaborate more on is these two components, which are less visited and less frequently discussed. First, about a tool that can be used to manage this iterative development of machine learning models within the training process, and then figure out how we can use Pythonic tools to monitor a machine learning model and identify different types of changes. And when it comes to these two, sub items, there are certain questions that we ask specifically within a training cycle of a machine learning model. We want to understand if our machine learning pipeline is reliable. For example, are we using the right feature extraction functions with the right model, with the right hyperparameter set all together? And we want to track that very accurately because once we have a good performance, we need to make sure that we use the exact same setting which has to be deployed into the external client facing environment. And the other thing is there are so many different combinations of these tools that can come together, and how do we deal with managing this chaos or this all sorts of combinations. And to do that, what I'm going to introduce today is this very recent tool that is gaining traction in the machine learning community, which is called MLflow. MLflow is a tool that has been developed by Databricks, which are the creators of Apache PySpark, to manage data science life cycles or machine learning model life cycles. And one of the key objectives is to do model tracking. That is because, as I said, there's a lot of chaos when it comes to training models. There are various different hyperparameter combinations. Then you make small alterations to your source code during this process when you detect certain assumptions that need to be incorporated in your training scripts. And this leads us usually to this, these are screenshots from my own previous past, where I would, make all these folders with various different indicators of the different combinations that I'm using in these different training sessions. And then even within these models, I would explicitly use Python to store certain statistics that would allow me to quickly go into this file and figure out, okay, where does the input data come from? What are the hyperparameters used? And what is the Git hash that was used, etc., etc. And this becomes a very chaotic and time-consuming thing. And especially when you have about 100 of these different instantiations, how do you then, with your human brain, figure out what is the most ideal combination? And finding these things is important as an objective data scientist, because you need to be able to reproduce your results, to do diagnostics, to demonstrate to other people that what you have come up with is stable and real. And you also need to, the moment you identify a good final, you want to be able to quickly deploy that to uh, production. And what MLflow provides you is a set of scripts and plugins that allows you to do this much more seamlessly than humanly manually taking care of it, and especially the fingerprinting process. And also it comes with plugins to various popular machine learning frameworks that allow you to easily use it. So how do we actually use this? this is, this could be part of your training script. So here we have an example where an elastic net model is being trained, and this bit is very common to any machine learning training and evaluate process. However, the additional parts that you have is from MLflow library itself. You have these helper functions that will allow you to log these different statistics and also log the exact model itself. And all you need to do is incorporate these commands in your training script. And what model MLflow will do is, at the background, it will then take all of these log feeds that are coming in from the training script when it runs, and you will have a world view of all of these models that ran and their metrics that you record. And here you can record certain parameters such as input data, the git hash, various different things can be saved. And then it also takes a fingerprint of the exact model that was created in that training session. So it makes exploring your models and managing the different versions of your models much more easier. And going forward, what it also allows you to do is, once you have all of these versions of the models, it also allows you to store things like the conda environment, the requirements that are prerequisite to running this model. And through MLflow itself, you can then create different versions of this machine learning model that you can deploy into different production environments. For example, you can create Python functions or Docker images that only does the inference part, which would, as a company, you might want to protect the training business logic. And in a situation like that, only exposing the production prediction part would make sense. If you want to do big data distributed machine learning, then it allows you to convert it to something like Spark objects. And if you want to deploy this model to a cloud service, it also provides you interfaces to do this. So, I mean, for me, it's like a game changer that allows me to manage this very chaotic process of maintaining models and managing them from development to environment. So now we looked at the shorter cycle, and in terms of the longer cycle, you have this thing. Once you deploy a model to the production environment, we need to monitor the model, because there are various different types of drifts that could happen in the data landscape. For example, there is this concept called concept drift, where the initial assumptions that the data demonstrated in the past are not valid anymore. So here what you can see is that the decision boundary is slowly changing over time. For example, we can look at sentiment analysis. The type of values that were valid 100 years ago is very different from now. For example, various different issues related to political correctness were highly acceptable of 10 20 years before now. What that means is the data itself is changing, and that leads and that demands for retraining models by refining our training data sets much more carefully. But we wouldn't be able to do that if we can't detect this. And what would happen is, we will only know this when a customer complains that the models don't perform as well as they used to. And at that point, we are losing business, we are losing brand reputation, etc. Then we also have data drift, where the concepts or the idea behind the prediction boundary remains the same, but the input data is changing over time. So we need to detect this as well, because this might be an early indication of concept drift. Or if our model is very dependent on the prior distribution of the training data, that would also mean that data drift will affect the predictions of our model. So due to these reasons, detecting these drifts are quite useful and important. And evidently AI is a Pythonic open source tool that you can use to do this. So in evidently AI, what you can do is, again, just like MLflow, you can expose your prediction API with sort of wrap it with evidently AI. which will allow you to look at how the features are drifting, look at if the label distributions are changing for different segments of your feature sets, etc., which will allow you to monitor the overall health of the machine learning services. And as I said, it's a matter of, uh, importing certain elements from the dashboard, and then, choosing what type of different statistics you want to see. You incorporate this in your Pythonic scripts, and then you can access the dashboards to monitor the health of your ongoing machine learning services. I highly encourage you to go to these websites and do a bit of tutorials to understand how it exactly does these things, so that you can use this to again minimize the chaos in your machine learning processes. So now I believe, in terms of, in a developer's perspective, I convinced you that when it comes to machine learning and data science life cycling, there are various different tools that are available in Pythonic ecosystem that we can use. Now we want to look at it in a strategic perspective, and one of the many wrong misconceptions that a lot of organizations have today is thinking that when it comes to artificial intelligence or data driven business, you have to go from zero to hero in 1 quarter, which is a very impractical thing to do. Uh, with time, with experience, people in the industry have formulated what is called the data maturity curve, which sort of shows different stages of data science or data maturity organizations can be in. Majority of the organizations today in the world are in key zero, where they don't have any data analytics projects going in their business. But the most sensible thing to do next is not to say, okay, tomorrow I'm going to build a data strategy, build a data lake, and start convincing people to use data centric approaches. That is not going to change, because you need to change technology, you need to change the processes, you need to change people, all of them at the same time, which is impossible. So one of the first steps one could take is to identify a few tasks that you can automate and which could benefit from AI or automation, and focus on these specific projects in isolation. This is risk averse because it doesn't impact the majority of the business. At the same time, in a strategic perspective, you can gauge how much return on investment one would get and how worthwhile it is to invest in these things. And once you have a few services like this, you can then try to understand, okay, what are the redundant bits that are being used by these multiple services? So can we build common resources that can be reused in multiple of these services in a way that it will further efficient, make it more efficient in our process. And from there, we try to slowly get into convincing people, where we are trying to say, okay, now there are these reports, try using these reports and use these reports effectively. So you are also triggering people to learn and familiarize with the new change of this data centric approach. And with these users and their feedback, you can now come up with a much more wider or much more holistic view of how you have to manage your data and how you need to make this data available to different stakeholders in the business, so that they can make use of the power of data the way they want, which is building this hub where people can access the data they want to do what they want. And only with that, over time, we could attain a company that has technological preparedness, the process in place, and also people with the right attitude to welcome and embrace data centric business. And as I said, the best and the only advice is you have to bite what you can chew at any given time, not to try to do all of this at once, because you need to make profits, you need to keep shareholders happy, you need to keep your customers happy. So when you're starting on, in the early stages, we are focused on isolated parts of this process. where we don't want to commit a lot of resources. And in an infrastructural sense, you have amazing cloud services right now that provide infrastructure as a service, and even machine learning training as a service, which could be used to start this journey, where you don't have to worry a lot about proprietary protectedness of the organization's models. You are okay for AWS to train your model at this point, and only when you gain a bit more maturity and when you understand what AI technologies are more important in terms of intellectual property or keeping proprietary within control the organization, you could then start thinking about sometimes alleviating some of these cloud services to your on-premise infrastructure, or completely moving into on-premise infrastructures in the long term when you have a better understanding of how to manage this journey. And this is about technology. And in terms of people, it is very similar, where you can start with much more disposable, flexible commitments like experts or consultants, where you help motivate them to identify very specific parts of your business that can be automated or semi-automated. Then with more understanding of how to manage expectations, objectives, etc., you then go to augment a team or a few personnel who would be part of the organization in a legal term, so that your intellectual property and business know-how is protected. And once you get a good grasp of how to manage people and what roles and responsibilities are expected of people, you can go ahead, sit in interviews, and with confidence identify the candidates who would do the job you need in the organization, at which point you can start thinking about having much more reliable or permanent data teams. And this is about people. And when it comes to process, again, we have this motivation from agile software engineering, where you do iterative improvements. And in data science, agile data science could in some ways looked at as the only way to go in this journey, because data science projects are very uncertain in terms of the outcomes. They are not as deterministic as software engineering projects. So you need to draw a mindset where you sort of look at small increments that are objectively measurable. For example, if you want to build a machine learning model for detecting reliable news articles, your first objective would be to formulate a data set of X number of observations that is labeled and reliable for doing this process. So you can, in 2 months, you can measure, have I gotten 12,000 observations or not? And are they balanced, etc., etc. Then you set the next sprint and say, I want to try these baseline models that have been tried in literature with this data set to identify what this data set means in terms of prediction for my business. And then in 2 months, you have a very deterministic outcome, which is you are using the models that are already there to determine, can I get to 60% with these models? Can I get to 70% of these models? And then you have the scientific process where you could say, okay, in the next quarter, I want to increment the F1 score of predicting in this data set by 5%. So you know exactly, at the end of the quarter, you measure the previous performance, the new performance. Is it increased by 5%? Yes, you hit the goal. No, you didn't. If no, then your follow-up analysis would show you why. And that way you can iteratively improve your data science products. So in conclusion, the first thing that I wanted to convince you today is that building data products is not a tense pull between the managers, directors versus the engineers or developers. It's good when you augment both of these parts together and think clearly together to have a much more smoother journey. And data science operations should be looked at as a cyclic process, mainly because of the uncertainty. You need to make iterative systematic improvements And I hope I showed you a various, ecosystem that allows you to tackle different parts of a data science life cycle process. And in a strategic perspective, it is sensible to follow something like the data maturity curve and do systematic and gradual changes in data capabilities, which also, as a human resource, gives you the understanding and experience gradually to work with much more complex challenges over time. And at the end, when it comes to data science, it is good to do iterative gradual increments, so that you don't have to drag the whole organization through a very steep transition, which also is likely to succeed. Thank you very much. And if you want more information about the work I do, there's my personal website. And if you have any questions, you can reach me at my email address. I also have a blog, which is not as active as one could be, but when I feel motivated and curious about certain things, I write about them. It was a pleasure speaking to you all, and I hope you have a good week ahead. And yeah, I think we can take questions now.
Since we have a few minutes left, I think we can move on to a Q&A round. So you can either ask your questions by raise hand option, and also you can use the Q&A tab. And I'll read out the first question that we have. I have been using MS Azure for machine learning projects like analyzing and predicting data of businesses. Is using this platform recognized in the industry, or should I use R and Python more often?
Yep, it's a very timely question. As I mentioned in the slides, it's always, it's more sensible and less risky to start with cloud-based operators. And Microsoft Azure is a very well recognized cloud-based service. There was a huge, even a huge controversy around Microsoft Azure winning the Pentagon data contract last year in comparison to AWS. So they are a well-recognized organization, and national health services in England recognizes them to be GDPR compliant, privacy preserving. So it's a very potential candidate. But at the end of the day, the caveat is all of this depends on your client's expectations. If they want to have a model that has a lot of, where they have a lot of control over, they own the intellectual property, etc., you need to read the fine prints of these cloud services and determine if these services are the ones for you.
We have another question. Could you explain what OSEMN, Microsoft 3DSP, Domino Data Labs, Lifecycle are focused on?
I'm afraid I am not very familiar with these specific standards, but my intuition would be they all are different variations of the basic life cycle that I presented to you today. In terms of the specific differences, I am not an expert to answer on that, but in a process perspective, having this iterative approach is the key, and having certain expectations, for example, the objectives that you want to achieve in different iterations being much more measurable and deterministic is one of the key factors to success. So the next question.
What are the difficulties when merging data from different sources into one unified data set?
Yes, I mean, that also is very dependent on the different businesses. And there are various different types of data. There's structured data, there's semi-structured data like JSON, then there's unstructured data like natural language. And based on the application, you have to merge them differently. And when it comes to requirement, it could be the downstream applications, it could be the amount of budget that an organization can afford, the amount of maintainability that a company can afford, and the type of strategic importance they see in data. So it's a very domain specific question, but you have uh, tools like PySpark or Apache Spark, which is the JVM version of it, which allows you to deal with various different types of data formats and give you capabilities to join them, merge them, stack them, slice and dice this data and move it around in various different data sources. And Spark is not the only solution. When it comes to big data specifically, there are thousands of different products in the ecosystem that focus on different needs, that some of which I spoke just now. And the key is to look at them and figure out what is the right tool for you.
All right, thank you for that answer. We have another question. Other than cleaning and visualization, what are the other things in data lifecycle?
So visualization may not necessarily be diagnostics. So diagnosing models is one of the most important and crucial parts of a data science life cycle. So for example, I saw this meme a few days ago where you have a outcome saying accuracy 99.9%, and then you have a junior data scientist that is very happy about it, and then there's a senior scientist who's having a skeptic look, that's like, that doesn't look right. So diagnosing the models is one of the key aspects of validating that your life cycle is complete. And I think that is one of the most important bits, and that could mean diagnosing in terms of feature distributions, etc., or using explainable AI techniques to explain your models to see if the patterns recognized by the model comply with the assumptions or knowledge you have about the actual data generation process. So I would say that is another important part that is not obvious, but falls under the human feedback short loop or the monitoring loop, where you see if the data is changing over time. And can you relate that to, for example, COVID, or Apple changing their policy on third-party cookies? So trying to reason why data changes allows you to be much more informed as a data scientist to build more robust models.
The
At
next
what
question
stage?
is,
Yeah. Yes.
what is the best tool for deep learning, skitlearn or TensorFlow?
Yeah. I would say between these two, TensorFlow, obviously, because TensorFlow is a library created for building flexible deep learning architectures. Uh, PyTorch is also another contender, especially in academia. PyTorch is fairly more popular compared to TensorFlow, but between them, I would say it's a matter of preference and your previous knowledge and experience. People choose to either go with PyTorch or TensorFlow. Like from TensorFlow 2 onwards, there are no major architectural differences between the two libraries. So I would say it could be either. Yes, so then we have at which stage the data science lifecycle that optimize the parameters. Usually you do that in the training and validation stage. Sometimes you might have to go to the feature extraction stage. If it is something like natural language processing, you might have to decide, for example, when you calculate stop words based on the number of times they occur in the vocabulary of the data set or in the training data set. You might want to analyze the word distribution and figure out, okay, I'm going to make a cutoff point here. So there are certain hyperparameters that you might want to tune during the feature extraction stage. But in general, from feature extraction, feature selection, model training, and validation, these four things are iterated in that short cycle, and that is during which you tune the hyperparameters.
All right. So I guess we can wind up the Q&A round now. Thank you everyone for patiently waiting and giving your fullest support throughout the session. Our special thanks to Mr. Bulathwela for joining us today and insightful session. Thank you so much.
Yes, thank you very much, everyone.
It's a wrap. Join the main session to witness the closing ceremony.